This question is from GATE 2019 Mechanical Engineering paper set 2, question number 39. A 4-bar mechanism is shown in the figure. The link numbers are mentioned near the links. Input link 2 is rotating anti-clockwise with a constant angular speed omega 2. Length of different links are O2O4 is equal to O2A is L and AB is equal to O4B is root 2L. The magnitude of the angular speed of output link 4 is omega 4 at the instant when link 2 makes an angle of 90 degree with O2O4. The ratio omega 4 by omega 2 is dash. Let's find out. In this mechanism, in order to find out this ratio omega 4 by omega 2, we will have to find the number of instantaneous center and then use the instantaneous center to find out this ratio. Because we know that instantaneous center has to stay stationary. It can be either on the body or out of the body. So for this mechanism, we will have to mark all those instantaneous center here. First, number of instantaneous center for this will be NC2, where N will be the number of links. So we have 4 links here. This O2O4 is also a link. So N is equal to 4. Therefore, number of instantaneous centers will be equal to 4C2. Can be written as 4 factorial upon 2 factorial into 4 minus 2, which is 2 factorial. So this gives us number of instantaneous centers in this one are 6. Let's mark those instantaneous center here. Let me just shift this figure in order to make space and mark the instantaneous centers. So we'll use the link numbers to show the instantaneous centers. O2O4 is named to be link 1. O2A is 2, AB is 3 and O4B is 4. These are the numbers already given to the link. So O2 is the instantaneous center, number 1, which can be written as I21 because it is between link 2 and 1. Then similarly, point A will also be an instantaneous center, I32. Point B will be I34. Point O4 will be I41. So these are 4 of them. The other 2 will be, one will be somewhere here downside, but we won't use that instantaneous center. We will use the one on the left side, which we can mark by extending the line passing through link AB and the one passing through link O2O4. And here we have the point of intersection of these two lines as I24. Net velocity should be 0 and therefore we can write the equation omega 2 into this distance to find out velocity at I24. So this distance is nothing but I24. This is a point. So I24 to I21. I24, I21. This is a distance between these two instantaneous centers. So this will be equal to omega 4 into I24, I41. This is distance between these two instantaneous centers. This is because net velocity at I24 should be 0. So we rearrange and write omega 4 by omega 2 will be equal to I24 I21 upon I24 I41. Now we have to find out these distances. So this distance O2O4, this is known to us, it is L. We need to find I24 to I21 and then we can add L to it to find out the other distance. So we'll have to use these triangles. It is given that this angle is 90 degree. Also, we can join point A to point O4. This is the diagonal of this quadrilateral formed by the links. So using these two triangles, triangle AO2 I24 and triangle AO2 O4, we can find these distances. But first, we'll have to find the angles also. So we'll need this angle. Now in order to arrive at this theta, we need to take into consideration the distances that are given. So this is L, and this is a 90 degree angle. So definitely these angles are 45 degree. Angles opposite to opposite sides should be equal. And one of the angles in the triangle is 90. So the other two definitely will be 45 degree angle. Now in this triangle, the one that I'm shading, we see that this side AO4, these two sides are root 2L. And from this triangle AO to O4, we also know that side AO4 should be also root 2L just by using Pythagoras theorem. Under root L square plus L square will give us hypotenuse is root 2L. So this triangle that I have hatched is a equilateral triangle because this side is also root 2L. All three sides are equal to each other. So the angles of the equilateral triangle should be 60 degree. Now in this supplementary pair of angles, two of them are 45 and 60. So the third one has to be 75 degree. This is 90 degree. So the remaining angle theta will be equal to 180 minus 75 plus 90. This turns out to be 15 degree. So theta here is 15 degrees. Now we can use theta in the right angle triangle in order to find out the unknown side. So the unknown side simply will be L upon tan 15 degree. You can write tan 15 degree in this triangle and you will get I24, I21 is L upon tan 15 degree. And then adding L to it again, you will have the other distance, this in the denominator. So substituting these values, we will have omega 4 by omega 2 is equal to, this is L upon tan 15 degree divided by, this is L upon tan 15 degree plus L. Computing this, we have 3.73 L upon 4.73 L. This gives us the ratio as 0.789. We need to round it off to 2 decimal places, so we can write it is almost equal to 0.79. Let's go back and fill in this answer. The ratio is 0.79. To learn more about instantaneous centers, you can refer to the NPTEL video, Lecture 26, Relative Motion 3 and Instantaneous Center. It's from the course Engineering Mechanics. The course is taught by Professor K. Ramesh. He is from IIT Madras. I hope this solution will help you clear your doubt. Thank you.